Now we are going into a little more detail on the threat isolation use case with ZIA when the users are accessing internet applications, and also with ZPA when the users are accessing private applications. So this is how you actually set this up. For ZIA, when users are accessing internet applications, there are multiple ways to define on what you would like to isolate. You can actually either use URL filtering policy framework, where you can define for a specific URL category what would the action be. So if you select the action as isolate and select an isolation profile, you're able to now define a policy where you can say the specific URL category you would want to isolate all traffic. A great example of this is actually miscellaneous URL category. So miscellaneous URL category is essentially all the URLs that have not been categorized so far. Now, sometimes these websites or these URLs very often contain high risk, suspicious websites. Now, a lot of customers try to actually block these, but sometimes blocking these websites comes at a business cost. For instance, it stops the users from accessing legitimate sites which are just newly created. But with this technology, what you can do is you can write a policy where you can say, for all miscellaneous websites, I would like to isolate. Now, you have struck a good balance between productivity and security, because users can still go and access these sites, but they will still be protected from any one of the suspicious or malicious sites that is running malicious active content. All of this, whatever you're isolating, still goes through our entire security engines. All of this is logged. All the context is carried forward in terms of the isolated browser, user location, and IP address. And what you can also see here in different logs entries is this is the user who was actually isolated. This was the policy action, and this was the location, and this is what different websites they were going to. Now, let's look at granular policy control. So we were talking of a policy that you can define using URL filtering with the isolate action. And there's something called an isolation profile. Now, there are two aspects to see here. One is to define what traffic should be isolated. And this is what you're defining in the URL filtering policy with a specific URL category. By the way, you can also do this in the cloud app control policies. The other action is that once a specific website or a URL category is isolated, what should be the user's interaction with that specific isolation browser? This is where isolation profile comes into play. You can actually define controls. Do you want them to copy paste? Do you want the clipboard control to be there? So for instance, what you can see here is that local computer to isolation, isolation to local computer, all of these are enabled. You can turn these off. Upload and download, you can enable or disable them. In fact, we also have controls where you can define if a user is allowed to put in their username password to a website. And that can actually be a very effective method to block credential theft. So for any high risk or suspicious website, you make it read only. The user can go and access the website, but they cannot put their credentials there. So there are multiple ways that cloud browser isolation can provide another layer of defense in addition to all the security capabilities that we have discussed so far. The steps are: you define the URL filtering policy with isolate as an action. You define what URL category, which user, which department you want to isolate. And then you also define the isolation profile on the cloud browser isolation admin interface. You can define like what level of control do you want, clipboard, file download, upload, also form post. You can also define isolation regions to be used, banners, and isolation experience schemes, and etc. The next piece that I want to talk about here is, so far we have looked at how you can actually define a granular policy from scratch. But we also wanted to build something very simple for our customers to use. With a single click, they can figure out what needs to be isolated and what not. So instead of burdening the customer with figuring out what destinations should be isolated, we have come up with something called AI-powered cloud browser isolation. With this capability, there's a single click button under the policy tab under secure browsing, smart isolate. As soon as you enable this, all the users, anytime if they are going to a risky, high risk destination. So we have an AI ML model that looks at different parameters that I'll talk about in a second and find out if the website or the domain is suspicious or not. If it is suspicious, it is automatically isolated. So customers don't even have to worry about specific URL categories that they need to isolate. They can still do that, by the way, but this allows a very quick and simple way for them to use browser isolation in a very efficient manner. Now, how do you identify suspicious domains? So we look at a lot of different information. We do heuristic analysis of the page structure, typo squatting, brand imitation, relationship to other domains. What is the page risk assessment that we have done, hosting location and ASN information. All of this is actually fed into an ML model, and we spit out a score to find out if this is a suspicious domain or it is not. So that is how AI-powered smart browser isolation works. Now, the next piece that I want to talk about is how you can actually use browser isolation to get data protection. So imagine someone's coming from an unmanaged device trying to access an internet SaaS application. And if you combine these aspects along with the identity proxy, you create this capability called the isolation proxy. So imagine a device can be considered managed, of course, if the authentication request is arriving via ZIA. You have client connector on the device, but it can also be an unmanaged device. Now, any authentication request to the identity proxy not arriving via ZIA would be considered unmanaged and will be isolated. All the SaaS traffic from the isolation browser will be proxied via ZIA and will be subjected to the same enforcement policies. So the same isolation profile that you are creating with specific applications going outbound on URL filtering, you can still create similar isolation profile to actually achieve data protection. So what you see on the right here is, for instance, these are the identity proxy settings where we have said that if the identity transformation rules are passed through Zscaler identity, the managed device is actually proxied via Zscaler and it's an unmanaged device, then isolate this specific session and use this specific isolation profile. Just to understand the workflow, this is how it actually happens. From an unmanaged device, imagine the user is trying to get to one of these SaaS applications like Box. As soon as they try to go through the Zscaler identity proxy to authenticate against this application, we intercept that SAML assertion. We send it to the IDP, which could be Okta or let's say Ping identity. Then the identity proxy automatically, based on the configuration we've seen in the last slide, creates an isolated browser session in a containerized environment. And then all of that is actually sent through the Zero Trust Exchange back to the user. And now, for instance, what you can do is if the user is coming from an unmanaged device, using that same isolation profile concept, you can say, I do not want any copy paste. I do not want to give any clipboard access. I do not want this specific user to be able to download any files, thereby enabling data protection using cloud browser isolation. The next section that I'm going to talk about is how can you use browser isolation for private applications. So when a user is accessing private applications through ZPA, you can also define a isolation policy within ZPA where you can, for a specific application segment, set the rule action to be allow isolation. And then you can again select a specific isolation profile. The concept of isolation profile is exactly the same on how it is for ZIA. And now this allows you to create a granular policy framework, allowing definition of what browser access traffic should be isolated. You can define clear policies on what private applications you want for this isolation to happen. And you can then enforce all level of data exfiltration controls. You can actually say, I want to disable clipboard, I want to disable uploads or downloads to this specific private application, thereby leveraging cloud browser isolation even to secure user access to private applications. Now, if we look at the ideal enterprise adoption of browser isolation, to summarize all of this, you can map it across two different axes. So on the x-axis here, I have the isolation deployment, and on the y-axis, I have the risk reduction. So you reduce risk to a lower extent, but it's very easy to deploy, is isolate risky domain categories. And this is where smart browser isolation comes into play, the single click functionality. After that, you want to isolate private apps. So that also reduces your risk further. You can isolate SaaS applications, which even reduces the risk of data exploitation or loss. And last but not least, you can also isolate high value targets. And when we say high value targets, these are specific people within your organization where you want to actually, for instance, C-level executives, where you only want to allow access to different sites through isolation for these specific users. So this is how all these different use cases can be solved with browser isolation across users going outbound to the internet to access internet applications to provide them security against any malicious active content, users going outbound to the internet for SaaS applications coming in from unmanaged devices, and users going to private applications using ZPA. You're also able to provide data protection and security capabilities to those users.